Hi, I'm Bethany, and I'm going to be presenting the genetic disorder of isovaleric acidemia. So, to start off, what is isovaleric acidemia? This is a genetic disorder that is an organic acid disorder. This causes abnormal levels of organic acids to be present basically all throughout the body, in the blood, urine, and in the tissues. Ultimately, this is a toxic accumulation within the body. The gene that is presented within isovaleric acidemia is the IVD gene. So to go a little bit more into that, it's located in all of the mitochondria of the cells, and every cell has mitochondria, so it's found in every cell. It provides the instructions for the creation of the enzyme isovaleric CoA dehydrogenase. Ultimately, this breaks down leucine, an organic acid. This allows the body to break down proteins, which are taken in by what we eat and drink throughout the day, and breaks those proteins into amino acids and then processes those amino acids down for energy that we can use throughout the day and to keep functioning. Now, what causes isovaleric acidemia? To the right, you can see a compound structure, and to the left, it goes into a little bit of an explanation of what can cause this genetic disorder. It's an inadequate level of the enzyme that breaks down leucine, and it's a mutation in the IVD gene, which we just went over. So the body is unable to break down amino acids, ultimately for energy is the main problem. Symptoms of this genetic disorder can appear within days of birth if it's an extreme case, later in childhood, or someone can actually have this genetic disorder and it be asymptomatic, which means no symptoms will ever show. A lot of the common symptoms you'll see in babies are failure to thrive, which means a failure to gain weight, or increase in growth, stature. There's also no appetite, a lot of vomiting, and then later on into childhood, you can have seizures, extreme lethargy, and then babies and children both present this very unique symptom, which is a distinctive odor of smelly feet throughout the whole body, which is caused by the accumulation of all the acids. The mode of inheritance is its autosomal recessive pattern, so both parents of the child must be carriers of isovaleric acidemia. To be affected with the disorder, a child must receive both mutated copies of the gene. So they'll get one from their mother and one from their father. Who is more affected? It's very rare. It affects about 1 in 250,000 people, and it can affect anyone. There's a study done, and it does not occur more in a certain race, ethnic group, geographical area. It really is, it can affect anyone, and both parents, as mentioned before, must be carriers of the mutated gene. To the right, I have a pedigree example. This is actually one that I created myself. I think it's a great example of if both parents are carriers, how they can have a child that is a carrier and that is not a carrier. The carriers go on, and if they marry and have children with someone who is not a carrier and is not affected, none of their children will have an effect of having the disease. But if they are a carrier and marry someone who has the disorder, it just shows how often their kids are going to have the disorder, if they're going to go on and marry someone who's a carrier or marry someone who is not a carrier, how that goes down and affects, honestly, multiple generations of children. So this was very interesting to me to study and look at. Genetic testing for isovaleric acidemia. There's actually a lot of tests out there for such a rare disease. There's currently 83 genetic tests that can be done. Most commonly, they'll be done in the newborn screening panel or in the comprehensive mitochondrial disorders panel. There's also the baby gene targeting panel. And then if you're older and showing symptoms, they'll just go ahead and do the isovaleric acidemia specific test. This can be done by a blood draw. And the panels that I mentioned are actually all done when the baby is first born. So you can pick and choose to have the isovaleric acidemia test included within those panels. Going a little more into it, all testing for isovaleric acidemia is optional. It's not required by the government, but if the child of parents that are carriers or have the disorder, automatically the doctor, the genetic counselor is really going to push and encourage the parents to get that child tested since they do have a higher likelihood of having it. Siblings of a patient who is diagnosed will also be pulled in and get tested since, as mentioned before, they might be older but might not be showing symptoms yet. So it's a good chance that if one child has it, someone else might have it or be a carrier. So they want to go ahead and test all the siblings. And as I mentioned, it can be done with blood draws, buccal swabs, or cultures. Treatment options, there's currently no cure, but not to say there won't soon will be. Upon being diagnosed, your treatment needs to begin immediately to prevent complications that can occur from the organic acids building up within your body. Certain treatments that are currently used the most to help the side effects of this genetic mutation are special diets that are low in protein, and then oral administration of glycine and L-carnitine. Both of these will help dissolve the excess isovaleric acid within the body. And these are my references. And thank you so much for watching. Hope everyone had a great end of the year and good luck on the final.